All right. We are live. So I'm just double checking. All right. Oh, there it is. All right. So for those just now joining us, appreciate that y'all are here with us today. Swim practice just got done. Lost my voice a little bit, just yelling a little bit. So I'm going to try and keep it. I have 2 viewers with us. Glad y'all are with us already. And so if you're here, I'm trying to figure out how to live. Oh yeah, if you're here, just kind of comment below, just to say, "Hey, I'm here," and so you could just say, "Hey, I am here." I know I'm I know I'm here, and I know there's 2 of y'all out there. You don't have to comment, but you're welcome to. And so the comments are just there for me to see. Here, Ty. I think Ty, nice to see that you're here. Good practice today. For those that don't know, Ty is one of my swimmers, and he is up and coming, and he's destroying it. He starting out at a good. But we are not here to talk all about Ty. Let's talk about math, because we got tests on block day. Hey, Jay is also here, and Jay is also another great swimmer. So I got both my swimmers here. Way to go, guys. Way to show up. So Jay already started off the block with a question for questions 13 to 14. Can you explain how to factor the expression problems, or just one of them, so I have a grasp on how to do them? Yeah, let's do that. Let's just move on to 13 and 13, 14, and 15, just because that's immediately. We will do every problem on the podcast. But since Jay's right here and he's starting us off, we will start with 13, 14, and 15. And then I'm going to go all the way back from 13, 14, and 15. And I'll start on question 1, because this is a live podcast. So let's start then with 13, 14, and 15. So that being said, I need to share my screen. And we got desktop 1, screen share. Boom, we're there. All right, so looking at 13, 14, and 15, these are factoring problems. And so what we have to do is factor the expression on the left side of each equation and then solve each equation. Now, can you also work over some square root method problems? Hey, Jay, let me ask you this, man. Is it okay if I start with number 1 and then kind of work my way down? Because eventually I will get to 13, 14, and 15. I'm going to do all of the problems on the review guide in terms of that. So I'm going to ask that real quick. Is that okay for me to do? Yes or no? Just starting at 1 and then moving on. I'll let you respond, Jay, waiting on you, and then we'll get going. If there is no response, I'm going to assume that's a yes, because we'll come back to this. So we will go back to 13, 14, and 15. We will look at all these overall. Sorry, let me get that out of the way. I'm just kind of opening up the study guide. So I don't want to waste y'all's time anymore. And looks like I'm having a little difficulty on my, oops. For those that just saw that, that is the wrong one. Trying to think what's happening here. Sorry, just having some technical difficulties on my end. And I'll get it up as soon as, fixed it. Okay. So, okay, got it. There we go. Sorry about that. All right, so starting at number 1. We're just going to start with number 1. The reason I want to start at number 1 is because when people are watching the podcast, we'll see what's going on here. And so looking at number 1 here, this is given the following table of values, find the quartic model. And so this is using calculator. And so if we're using the calculator, what we want to do is input this data. Now, a lot of you might be questioning, how do we input this data? So I have some values for X and I have some values for Y. So the way that we input this data, we're going to hit stat, and then you're going to hit enter on this edit. Edit's going to give you 2 tables. Now, I've already put in this data. Again, if you have data already there, you can go up and just clear that, hit clear and enter. That'll clear a whole set of data. So then all you have to do is input all the rest of that data. These are essentially giving us a couple of data points. Can we create a quartic model or a quartic quadratic equation? And so after we've set the table, made the values for the tables, we're going to hit our stat button again, because what we're looking for is this quartic model. Now, if I'm going to find that quartic model, I'm going to go to calc. You have 3 different types of regression that I can ask: the quadratic, the cubic, and the quartic. Since this is the quartic model, we're going to start with the quartic regression. Make sure X list is your first list, your Y list is that second list, and then you're going to hit calculate. Now you're going to get this thing that looks like X to the 4th plus bx cubed plus ... plus c. Basically what that is saying, this is the standard equation for a quartic polynomial, or polynomial to the 4th degree. And from that, what we're going to do is essentially just copy the values for A and plug it in. So we're going to do 2 decimal places here just so that we don't run out of room. I'm going to pull this up on the side so that I can read it. So, because once I start writing on my tablet, that calculator is going to go away. And so that being said, on the calculator, I have it. Let's see if I can adjust. I think I can adjust this so that we have both. Yeah, there we go. So adjusting it where we have both. We're going to set it where Y will equal 984.38 x to the 4th. The reason that's x to the 4th here is because the A value goes with x to the 4th. And then we're going to subtract that from 6,631.48 x cubed. Now, the reason we're subtracting, notice what is this value? This value is a B, which is negative. So that's going to be negative 6631.4. And then we're going to go to the next one, which is the C value. And the C value is 16498.68. Now, notice that there's an ellipse. You're not going to draw an ellipse here. This is the standard equation. So we're going to continue that with an x squared. Now, I am running out of room. So for D and E, I'm going to write below. So for this x squared, we're going to subtract that. So we're going to subtract. I'll just keep going writing on the side here, which isn't the best way to do it, but that's what you do when you run out of room. And that will be 17,000. Oh. 954.69 x. And so that last value is the E value, and that's going to be our constant. And then we will add that to 7208.88. I'm just going to rewrite this just a little bit so that when I show this to y'all that it won't be like so atrocious. So we subtracted minus that 17,954.68 or 69, sorry. I did it again. Minus 17,954.69x. All right, good. And so that's for the question 1. Now, what I'm going to do, I'm just going to keep going through this. I'm not going to ask, are there any questions? So if you do have questions as I'm going through the problems, just ask away. So question 2, we're writing each polynomial in factored form. List the zeros and the multiplicity. So we need to first factor this. And so if I'm going to try and factor this equation, what I'm going to do here is find out, is there any common factor? So I'm looking for essentially the greatest common factor. And again, the greatest common factor is looking at each term. Is there something in common, something that each term has? When I'm looking here, I see each term has an x. So what I can do is I can factor that out. And so I'm going to factor out the x to get x squared minus x minus 12. Now, since we're trying to write it out in factored form, we need to fully factor this, meaning I need to find something that's going to multiply to negative 12 that adds to negative 1. And so the factors of 12 are 1 and 12, 2 and 6, 3 and 4. If I'm looking at negative 1, that's definitely going to be coming from from 3 and 4, and that will be a negative 4 and a positive 3. Another way to think about it is we're just going to take an answer that adds to negative 1, and then another answer that multiplies to negative 12. And the 3 and negative 4 make that true, as well as here. And so we're going to do x times 3, or x times x plus 3 times x minus 4. We don't need to solve it. All we need to do is, we do need to solve it. But once it's factored, we need to list the zeros. What it means by listing the zeros, we need to assume that this is essentially equal to 0. And we're going to set where each part equals 0. This x here is essentially like in parentheses. And so we're going to set this x equal to 0, this x plus 3 equal to 0, and this x minus 4 equal to 0. So to solve for our zeros, we're going to just subtract 3 on both sides to get x is negative 3, add 4 on both sides to get x is equal to 4. But this last one, we just leave that as is. So we have x is equal to 0, x is equal to negative 3, and x is equal to 4. We also have to state the multiplicity. And so if we're stating the multiplicity, what that means is I'm saying, hey, how many times is 0 our x? Or is 0 our solution? And so since 0 only occurs one time, it'll have a multiplicity of 1. Then x equals negative 3 will have a multiplicity of 1 as well. And x is equal to 4 will also have a multiplicity of 1, because all of these occur one time in our solution here. So let's take a look at 3. Very similar problem. When we're factoring this is actually a difference of perfect squares. And so for a difference of perfect squares, what that means, if you have like an x squared plus, well, we'll just work out the problem. I won't do the basic. Difference of perfect squares mean I'm going to take the square root of the first term, which is 2. And when I square root, I'm going to put 2 in both. Then I'm going to take the square root of x squared. And whatever that square root of x squared should give me x. From there, I'll put a positive in one parentheses and a negative in the other. So I'm trying to find my zeros. So again, we're assuming that these are equal to 0. So what we're going to do, we're going to set 2 plus x equal to 0 and 2 minus x equal to 0. So to solve for x here, we're going to subtract 2 on both sides. So x is going to be negative 2. Subtract 2 on both sides again to get negative x is equal to negative 2. But there is a negative there. So I'm going to essentially divide by that negative 1. So x will be negative 2 and 2. But don't forget that multiplicity. And so x will equal negative 2 with a multiplicity of 1. And x will also equal 2 with a multiplicity of 1. And again, multiplicity is just based off of how many times does the answer occur. And so now let's move on to 4 and 5. This is kind of working the other way now. So write a polynomial in standard form with the given zeros. So when it says with the given zeros, that's essentially saying that, hey, x equals 1, x equals 1, and x equals 2. So those are your zeros. And so what we need to do is write a polynomial. So to write a polynomial, we're essentially going to say, hey, y, make sure y is equal, because a polynomial is an equation. We're going to say, hey, let's subtract 1 on this side, and that'll create the polynomial of x minus 1. Let's do the same process here and the same process here. Nope, that shouldn't be a plus, that should be a minus. And so what we're going to do now is we're not looking for zeros, we're looking for our polynomial. And so for our polynomial, to find that, what we're going to do is distribute the first two. So I'm going to do x times x. So I'll bring down this x minus 1. I won't use that first. I'll use that later. So I'll do x times x to get x squared. X times negative 2 to get negative 2x. Negative 1 times negative x, and negative 1 times negative 2 to get a positive 2. When I simplify that, that'll give me y is equal to x minus 1 times x squared minus 3x plus 2. So far, so good. And again, we're not solving this. We're just making a polynomial. So what we need to do now is we're going to distribute this x to each term. So x times x squared will give us x cubed. X times negative 3x will give us negative 3x squared. Then x times 2 will give us a 2x. I'm then going to distribute that negative 1 to each term. So I would get a negative x, a positive 3x, and then a negative 1. From there, we're going to combine our like terms. And so that would give me a x cubed minus 3x squared. This negative x should have been an x squared. So that should have been not negative 3, but negative 4. X, that's a mistake I made on mine because negative 1 times x squared is negative x squared. Then we'll do negative 1 times negative 3x. Now we're combining like terms of x, so 2x plus 3x to get 5x, and then 1 for our constant. And so, not 1. I messed up again. That shouldn't be a 1. That should have been 1 times 2 is 2. That's a mistake. So right here, negative 1 times this power 2 should have been a negative 2. And so then our final answer is this lovely polynomial. Let's keep it moving. And so to keep it moving, let's take a look at number 5. So write a polynomial in standard form with the given zeros. And so with the given zeros here, that's essentially saying x is equal to negative 3, x is equal to 0, and x is equal to 1. So if I'm going to write a polynomial, I'm going to add 3 on both sides, which would create an equation. Here, I can't really do anything, so that's just going to be an x. And then here, I'm going to subtract that 1. I'm going to do the same process I did last term. I'm going to start with the middle and distribute to the outside. The order doesn't really matter on how you distribute these, as long as you're distributing. So then that would give me an x squared minus x. From there, we're going to FOIL. So we'll just do x times x squared to get x cubed, x times negative x to get negative x squared, 3 times x squared to get a positive 3x squared, and then 3 times negative x to get a negative 3x. From there, we'll combine our like terms. And our like terms then would give us an x cubed minus 2x squared, not minus, plus 2x squared minus 3x. And there we go. We've done 5 problems. So far, so good. Averaging about 3 minutes a problem, which is a good speed to go at. Moving on. Divide using long division. And I know this is like the bane of everyone's existence, but again, I just ask that during this time, you just stay with me, stick in, and dig it in. And so if we're dividing using long division, what we need to first do is set up our divisor. And so that means we're going to do x minus 2 divided by, get a nice long thing here, x cubed plus 3x squared minus 2x minus 4. And so to solve this, what we're going to do is first take a look at, okay, for x cubed, What divides into x cubed? X. I'm taking the leading term of my polynomial dividing by the leading term of my divisor. That's going to give me x squared. So that tells me x squared goes on top. From there, I'm taking that x squared and distributing it to x minus 2. And when I distribute, I would get x cubed minus 2x squared. So then that'll be x cubed minus 2x squared. From there, we switch the signs. So we'll change positives to negatives and negatives to positives because the goal is to essentially cancel out that leading polynomial. So then when I add these two, this will be 5x squared. Now, since we're dividing binomial, we always need to create a binomial. So we'll drag down that negative 2x. And so what we're going to do is find out how can I get this 5x to be a value. So for this, let me get some other colors. So for that 5x squared, I'm going to divide it by the x. And in this case, it'll give me a 5x. So that means my 5x will go up top. The reason that I keep adding it is because they're positive numbers. And so what we're going to do with that 5x is we're going to take that 5x and distribute it to x minus 2. And so when we distribute, we'll get 5x squared minus 10x. So we'll put a 5x squared here minus 10x there. And then change our sign. So we're going to change positive negatives, negatives to positives. Eliminate that polynomial, and then that'll leave us with an 8x. And then we'll bring down that negative 4. So last but not least, I'm looking at 8x and the x and doing some dividing. Taking, okay, how many times does x go into 8x? Or what is 8x divided by x? It is 8. So we're going to take that 8 then and distribute it to x minus 2, which will give us 8x minus 16. So I'm just going to plug in this 8x minus 16 here and change our signs. So when I change our signs, that becomes a negative. This becomes a positive. Cancel that out, leaves me with a 12. Now with this 12 here, 12 does not divide into x. And because it does not, that then is going to be our remainder. I forgot to bring the 8 up last time. So then our remainder will be 12 over our divisor. So that means my final answer is x squared plus 5x plus 8 plus 12 over x minus 2. So we'll repeat this process again. And so looking at number 7, divide using long division. So long division, again, same process, setting up x plus 1 and a nice long polynomial. But I want you to notice something here. These need to be in standard equation, meaning if x to the 4th is the highest, it needs to be x cubed, x squared, x, and a constant. Does this equation match this equation here? No, it does not. And so what we need to do is develop placeholders, meaning that if I have x to the 4th, I'm going to add a 0x cubed plus a 0x squared minus the x plus the 2. Now, the reason I'm doing that is because I got to have this standard form. And I'm going to erase this just so that it doesn't take up space. So first off, we got to take that x to the 4th and see, okay, if I have x to the 4th, divide that by the x, what do I get? I get an x cubed. So I'm going to take the x cubed. And because with the x cubed, I'm going to distribute it to this x plus 1. If I do that, that'll give me x to the 4th plus x cubed. So I'll have x to the 4th plus x cubed. But notice now, here we subtract, those cancel. But what we're looking at after this subtraction is also changing this positive sign into a negative. So now we're looking at a negative x cubed. So this is again a polynomial of 2 terms, or also known as a binomial. So we're going to bring down the x squared. We're going to take a look at this negative x cubed and then essentially dividing it by this x. That then is going to leave me with a negative x squared. So that means negative x squared is going to go on the top up here. And I'm going to distribute a negative x squared to x plus 1. When I do that, that'll give me a negative x cubed minus x squared. So I'm going to plug in the negative x cubed minus x squared. And when I change my signs, look what happens. These cancel, and now I'm left with a positive x squared. So we'll bring down this negative x and continue our dividing process. And so, Michael Carr, I'm seeing that graphing problems that we might see on the test while I'm struggling with graphing. Yes, we can. Yes, we can do that. I will take probably a short break for questions before we hit the review questions. So we're going to go on to number 18 eventually, and then we'll do those review questions. And so looking here for x squared minus x, I'm looking at, what am I looking at? Oh, I'm looking at x squared minus x. We're going to take this x squared divided by x. That's going to give me an x here. So what that means, I'm plugging the x on top of my little house, and then I'm going to distribute it to an x plus 1, which will give me an x squared plus x when I distribute. And so that will give me x squared plus x. And so we'll change our signs. When we change our signs, that'll give us a negative, which cancels out here. This plus becomes a minus. Now we're looking at negative 2x with bringing down this plus 2. All right, so last but not least, we're going to take this negative 2x, divide it by the x, which will give us a negative 2, which means we're going to distribute a negative 2 to x plus 1, which is negative 2x minus 2. Plug that guy in and change the signs. Notice that when we change the signs, that becomes a positive. That becomes a positive. Everything cancels. Well, that doesn't cancel. That'll add up to 4. And so, again, this is a positive 4. Does 4 divide into x? No, it does not. I did it again. I forgot to bring in that negative 2. 4 does not. And so what we're going to do is add our remainder, which is going to be 4 over x plus 1. And so our final answer would be x cubed minus x squared plus x minus 2 plus 4 over x plus 1. X plus 1, and that's our final answer. So 7 problems down, fair amount to go. Probably won't work out all the review questions. I'll just work out the ones that people have questions on. And so that will happen as we, once I get to that mark. So the next question we're looking at is dividing through synthetic division. This is what a lot of us like the most because synthetic division is quick, it's fast, and I think it's a lot easier than synthetic division. So if we're dividing using synthetic division, what we have to do first is identify your 0. And so to identify the 0, you're going to set that x plus 1 equal to 0, and then subtract 1 on both sides, so you'll find out that our 0 is negative 1. And so once you find that 0 to be negative 1, what we're going to do is bring out these values. So these values for synthetic division, I'm looking at the leading coefficients of each value. So that'll be a 1, then a negative 3, then a negative 1, and a 3. So the way that we do synthetic division is we bring down the 1 and then multiply 1 times negative 1, which will give, in this case, give us a negative 1. And then now we add down, so we'll have negative 3 plus negative 1, which will give us a negative 4. Then negative 1 times negative 4 to give us a positive 4. Add to get a positive 3. We'll multiply to get negative 1 times 3, which is a negative 3. And this last box here is our remainder with a remainder of 0. So if the remainder is 0, it is a factor, but I don't care right now if it's a factor or not. All I'm doing is asking for you to divide. So if all we're doing is dividing, our final answer will be x squared minus 4x plus 3. This is what we get when we divide. The reason I know it's x squared, this represents your x cubed column, your x squared column, your x, and your constant. When you do synthetic division, you're essentially dividing x cubed divided by the leading term of your divisor, which is x, which leaves it to be x squared. This means this is your starting term or starting degree of your polynomial in the bottom. So make sure that if we're starting, that's how we're starting, is with that leading degree of x squared. And so let's continue the race. Do another synthetic division problem. Synthetic division, notice here that it's the same idea as what we did on long division. You got to have placeholders if you're missing. So I have an x squared here. There's no x, so I really need to include a 0x right there. So first off, for synthetic division, we're going to set our divisor equal to 0, so we find out our 0 is 1. And so then we're going to bring in the leading coefficient. So I have a leading coefficient of 1, and the coefficient for x is 0, and then the constant is 3. From there, I'm just going to do this quickly rather than the short way, like last way, or long way. So we bring down the 1. 1 times 1 will give us 1. Add these two to get 1. 1 times 1 is 1. And then we have a remainder of 4. Now, with this remainder here, what we're going to do is, because the x squared was our leading degree, and we divided it by a polynomial with a degree of 1, that means x will be our first term, and we'll add that to 1. This is known as your remainder. And so with the remainder, what we're going to do is add the 4 over the x minus 1. And voila, synthetic division. Now we're looking at solving by graphing. Now, to solve by graphing, the key is to get the equation equal to 0. And so what I'm going to do, I'm just going to subtract the x and the 3 on this side. So I'm going to subtract x and add 3 to both sides. So when I do that, that'll give me 0 equals x cubed. I'm going to do some rearranging as well. Negative x squared minus x plus 7. So I just rearrange it where it's in standard form. So if I'm going to solve this by graphing, I'm going to plug it into my calculator by doing x cubed minus x squared minus x plus 7. Graph that. I'm going to hit this nice little graph button, and it's going to pop up. And I'm trying to solve by graphing. And since I'm only solving by graphing, I see that it's like somewhere in between these two values. I'll blow this up just a little bit so that we can see. It's in between 1 and -1 and -2. So to find that 0, what we're going to do is by doing the left and right bound. You can't use the table, and you can't just guess. So to do the bound, we're going to do second trace and hit that 0 right here. Notice that says left bound and x is equal to 0. That means that x is at the 0 mark right now. Every time I move left, I'm going further down. It looks like this 0 is less than -2 and greater than -2 and less than -1. So what I want to do is find on the left bound a value that is greater than -2. I'll just use this one. It could be any value that's greater than -2. I'll hit enter there. And now I need to find a value that's greater than, or need to find a value that was less than -2 and greater than -1, which in this case would be -1.3. I can use any of those values. So when I do that, I'll get the left and the right bound, then hit the enter, and it should be -1.77664. I'm fine if you just round it to -1.78. I'm perfectly fine with that. Now I know it's like, oh gosh, we gotta find the rest of the zeros. Well, in this case, with the fraction, I'm fine with just leaving it as is, just solving by graphing is finding that 0. So let's look at another one to solve by graphing. If we're going to solve this one by graphing, let's plug it in. And so I guess the first question we got to ask, is it equal to 0? Nah, it's not. So what we're going to do, I'm going to add 3x cubed on both sides, kind of do this more step by step, to give me 4x cubed plus x is equal to 3x squared. And then I'll subtract 3x squared on both sides. You get 4x cubed minus 3x squared plus x. Now, I know I could do this by graphing. I could also do it by hand too, but we won't focus as much on that right now. And so to solve this, we're going to graph 4x cubed. Oops, hit a double x there. So 4x cubed minus 3x squared plus x. And we'll graph it. So it looks like it only goes through one of these zeros. And so let's do this. To find this, we're going to go second table. And look, I can use the table to find wherever there's a 0 for y, that means there's a 0 for x. So that means the 0 is 0. You could also do the eyeball test, which the eyeball test is just looking, hey, it looks like it goes through 0. So x is going to be equal to 0. To continue to solve this more fully, what we can do is taking this 0, do synthetic division of our problem. So 4, -3, 1, and 0. I'm just using this polynomial here. So let me do that. I'm using this polynomial here for synthetic division. I found one of my zeros. I'll bring down the 4. 4 times 0 is 0. Bring down the -3, which is going to be at 0 times -3 is 0, 1, 0, 0. So no remainder. So that's going to be leaving me with 4x squared minus 3x plus 1. You could continue to go on and solve this if you would like. But for me, rather than doing all this effort, I am perfectly fine with you just leaving the answer as 0. So you don't have to worry about that. If it's just solved by graphing, tell me the zeros that are in that calculate. Now, if it says solve by graphing fully or find all of the zeros by graphing, then that's when you have to do that synthetic division. So here's where we get interesting. For 12 to 17, these are our factor questions. And so will you have to solve these by factoring? Yes, you cannot just solve them by your calculator. And so there are 2 equations I want us to write down that you'll be given for the test. And that they are a cubed plus b cubed is equal to a plus b is equal to a squared minus ab, plus b squared. And a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. And so with that, the way that we use these sum and difference formulas, we have to look and see, is this a cubic binomial? So this only works for cubic binomials. If we're looking at solving means find x. And so with that, I'm going to copy this real quick. Nope. I want all those letters. Yeah, give me that. All right. Actually, that down. All I want is that. Sorry, I'm just doing this so that when I move on to other problems, I can just copy and paste. So to solve for factoring, we're going to factor. By factoring, I need to find the value of the cubic root of x cubed. That means what times itself 3 times gives me x cubed. In this case, x. So that tells me a will be equal to x. And then I'll do the same thing for 8. What times itself 3 times gives me 8. In this case, it'll be 2. So to factor this, I'm just going to use this half of the equation. All you're using is this half of the equation. Oh, wait, this isn't an addition. This is a subtraction problem. Using this half of the equation. And so we're going to do just plug in wherever you see an a, plug in an x, wherever you see a b, plug in a 2. So that'll give me x squared. I know it's an x would go in the a and a 2 would go in the b. I'm just going to switch that up. So that'll be 2x plus b squared, which b squared is essentially 2 squared, which is 4. Now, since I'm solving, I'm going to set both of these parentheses equal to 0. So that means x minus 2 will equal 0, and x squared plus 2x plus 4 will equal 0. So to solve the first one, I'm just going to add 2 to both sides. So then x will equal 2. That's good so far. Now I'm going to look here. Here's the thing. When you're using these are not factorable, which is a neat thing to remember. And because they are not factorable, what we need to do is solve it through the quadratic equation. Now that is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're using that quadratic equation here. And so to solve this, what we're going to do is identify your value. So 1 is our a value, 2 is our b value, and c is 4. And so we're going to do negative 4 plus or minus the square root. Oh, I messed that up. Not negative 4. Negative 2, because that's our b value, plus or minus the square root of b squared minus 4ac all over 2a. And so, and I'm just going to box this out a little bit. In the case of a is 1. I'll box it out later. And so what we need to do is just kind of simplify one at a time. One neat thing here is that if we do 4 times 1 times 4, that's going to be 16. 2 squared will just be 4. So this is actually going to be 4 minus 16. When we solve for that, that would actually be negative 2 plus or minus 4 minus 16, which is the square root of negative 12 over 2. Negative 12 gets broken up as 4 and 3. Here's the thing. If you don't know how to break up and reduce radicals, leave it like this, but with a I on the outside. But since negative 12 breaks up to 4 and 3, and 4 is a perfect square, meaning that we have a group of 2 here, this simplifies to negative 2 plus or minus 2i root 3 over 2. And so what we're going to do is divide negative 2 and the 2 on both ends, which will give me a negative 1 plus or minus I root 3. And that is our final answer. So the final answers, if you want to list them all out, would be negative 1 plus I root 3, negative 1 minus I root 3, and positive 2. Those are our answers for 12. I know it's a lengthier problem, but it just takes time. So let's move on to 13. So looking at 13, what we're going to do is try and factor this. Now, when we're factoring this, we need to look and see what things are going on, what's in common. Notice that I have a t to the 4th in both of these. So I can factor out t to the 4th, and that'll give me t to the 4th times 4t squared minus 1 is equal to 0. So that 4t squared is a pretty unique one because that's essentially the difference of perfect squares. So that'll be t to the fourth times 2t plus 1 times 2t minus 1. And so since we're solving these, we got to find values for x. Solving means find value. Don't just have it where x is factored. So what we're going to do is solve. So that means I'm going to set this t to the fourth equal to 0. The 2t plus 1 equal to 0. And the 2t minus 1 equal to 0. And so for the first one here, notice that this is to the fourth power and it's equal to 0. Basically, that means 0 times 0 times 0 times 0 will give me 4. So our first answer will be 0 with a multiplicity of 1. Now, if you have multiplicity in one part of the problem, you have to specify it in the rest of the parts of the problem, meaning that when I solve here, I'll subtract the 1 on both sides to get 2t is equal to -1. Divide that 2 out. So then t would be -1/2. And so we need to specify the multiplicity. So this would also have a multiplicity of 1. And last but not least, I need to add 1 on both sides to get 2t is equal to 1. Divide that 2 out. So then t will be 1/2. This is a multiplicity of 1. So our final answer is t is equal to 0 with a multiplicity of 1. Or not 1. That should be a multiplicity of 4 because it happens 4 times. T is equal to 1/2 with a multiplicity of 1. And so let me just correct that real quick with the blue. Fine if it's fine if it's fine. All right, next one. We're going to factor the expression on the left side and solve. So when you're factoring, you got to identify, okay, what is in common with each part of my terms? So I look at x cubed minus 5x squared plus 4x. The value that is common is this x. So that'll leave me with x squared minus 5x plus 4 equals 0. So what I'm going to do, I'm going to set both parts equal to 0. So I'll set x equal to 0 and x squared minus 5x plus 4 equal to 0. Now with the x equals equal to 0, I can just let that be as is. That's fine. That's 1, 0. We're good. And so to find the other zeros here, I need to factor this. So the factor, we're going to look for something that multiplies the 4 that adds to -5. Now the multiples are 1 and 4, 2 and 2. Now one thing that is cool, we have 2 negatives multiplied to give us a positive, so I can use those values. So then that'll give me x minus 1 times x minus 4. And when I solve these, give me x minus 1 equal to 0, x minus 4 is equal to 0, add 1 on both sides where x is 1, and then add 4 on both sides where x is 4. And so my answer is x is equal to 0, x is equal to 4, and x is equal to 1. Notice that I'm not stating the multiplicity because I didn't have one that needed it. Looking at the next one here, we got 8x cubed plus 1 is equal to 0. This is going to be using these equations, those cubic equations. And so I'm going to take the cube root of 8x cubed, which in this case is going to be 2x. I'm also going to take the cube root of 1, which will give me 1. And so what we're going to do is use the equation where we're adding. So we're using this one this time. So that would give me 2x plus 1 times 2x squared. Now 2x squared is just going to be 4x squared because that's just taking 2x and squaring it. Subtracted by AB, which in this case will just be 1 times 2x, plus b squared. And b squared would be 1 squared, which is just 1. Now remember that I said that this part is not factorable. So we're going to have to solve that part with the quadratic equation, but I'm going to solve this part first. So I'm going to set this 2x plus 1 equal to 0. So that means I'm going to subtract 1 on both sides to get 2x is equal to -1. Divide both sides by 2, so x is going to be equal to -1/2. And from there, I'm going to take a look at my quadratic equation. So quadratic equation means I'm going to set a equal to 4, b equal to -2, and c equal to 1. And so that means quadratic equation-wise, it's going to be negative of -2 plus or minus the square root of -2 squared minus 4ac all over 2a. Or that a should be a 4. And so this will give us, when simplified, this -2 squared is really a 4. -4 times -4 is a -16. So then that'll give us 2 plus or minus, again, negative square root of 12. What do you know? That won't always happen, but sometimes it works in our favor. And we already know the factors of -12 are 4 and 3. I kind of skipped ahead there. And so in the denominator should have just been 2 times 4, which is 8. So when we simplify this, we should get 2 plus or minus 2i root 3 over 8. Thing is here, these things simplify, meaning that if you have something in common with 2, and here, if those were too much. So some of those simplifies at 2, 2, and 8. If those three all have a value that is in common, we can divide this by a common factor, which in this case is 2. And so our final answer then would be 1 plus or minus I root 3 over 4. So that means this is an answer with that -1/2. We can't forget about that. So we are now reaching the 16, 17. So 16 and 17 are 2 factoring problems. So we got 2 more factoring problems. And we're going to take a look at the review questions. And I won't do all of them. And for those that are watching, I'll just ask, hey, what review questions that you want to do? And then if no one responds, I'll send a reminder out when I'm done and starting the review. And if no one responds, then I'll just pick and choose some that I think that are good to look at. So to factor the expression on the left side of each equation, we're going to, again, finding that value for x. To factor this, we're going to factor it as if we were factoring the x squared plus 8x minus 20. The only difference is rather than splitting it up as x and x, we're splitting it up as x squared and x squared. I'm going to erase this because I know that confuses people sometimes. And so I need a value for -20 that adds to 8. So looking at my factors of -20, that's 1 and 20, 2 and 10, 3 doesn't work, 4 and 5. So something that adds to 8, well, if I had a positive 10 and a -2, that'll work. And so what I'm going to do is, since this whole thing's equal to 0, we're going to get this x squared minus 2, set that equal to 0, get this x squared plus 10, set that equal to 0, and get at it. So since I'm in the x squared minus 10, I'm going to just subtract 10 on both sides to get x squared is equal to -10. Take the square root of that value. So x is going to be the positive negatives of -10. But again, we can't have a -10 in that denominator. Or not in the denominator. We can't have it underneath the radical. And so we're going to move that I out in front. And by out in front, it's in front of the positive negative sign, but behind the root 10. So that's how we solve the second one. Let's kind of go back and look at the first one. So I'm going to add 2 to both sides. So then that'll give me x squared is equal to 2. When I square root, I'll get x is equal to the positive and negative square root of 2. Those are your final answers. You have essentially root 2, negative root 2, I root 10, and negative I root 10. Those are your 4 answers. I'm fine with you kind of circling your answers. That's perfectly acceptable for me. Now the last one here. We are factoring the expression on the left side of each equation, then solve each equation. So to solve it, this one's a little tricky, but we have x to the 6th rather than x to the 4th. And so to solve this, rather than breaking it up as x squared, what do you think we would break it up as? X cubed. And so when we break it up as x cubed, we're going to take a look at 64, looking at something that multiplies to 64, that adds to 16. So that can be 1 and 64, 2 and 32, 3 does not work, 4 and 16, 5 does not work, 6 does not work, 7 does not work, 8 and 8. So can any of these add to 16? The last one can. So that means we'll add 8 to both sides. Now the question is, how can we solve these? So essentially, because they're the same, they repeat. And because they repeat, we're going to have to use our equations here. The cubic binomial a cubed plus b cubed. So I'm going to just write that equation that we're going to use. We're going to use the a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So if I solve for one of them, I'm fine. It just means all my answers will have a multiplicity of 2. So when I solve, I'm going to have a as my x value, b will be 2, and so that will be x plus 2 times x squared minus 2x plus 4. And when I solve for this x plus 2, I'm just setting that x plus 2 equal to 0, where x is equal to negative 2. So far, so good. And then I'm going to set, for this second one here, x squared minus 2x plus 4 equals 0. Well, again, this is not factorable, so we're going to have to use the quadratic equation, where a is 1, b is negative 2, and c is 4. And so to do that, we'll have negative 2 plus or minus square root of negative 2 squared minus 4ac all over 2a. So that will give me a 2 plus or minus the square root. This will essentially be a 4. That'll be a 16, so we'll get a negative 12. Hey, I think we've seen this problem before, because this then simplifies to 2i root 3. And then all those 2's divide out to give me a 1 plus or minus I root 3. Now, here's how we have to write out our answer. And so our answer needs to be, I'm going to erase this just so that we don't get confused. Since this happens not once but twice, our final answer would be negative 2 has a multiplicity of 2. 1 plus I root 3 has a multiplicity of 2. And then 1 minus I root 3 has a multiplicity of 2. So this is a more complicated factoring problem, but it's just one that you just kind of have to think through and work out. And that's it for just the content of 6.1 and 6.4, roughly done in an hour. So I'll give about a minute for those that might be live streaming, because I do see I have 3 viewers. I'm not sure if y'all are at the computer or not. And then you can just kind of say, hey, can we work over some review questions? Maybe we can do one of each, or maybe we can just kind of, I'll just spitball and see what happens. And I'm also going to go get some water real quick. I'm running out. Oh, I did think somewhere on our study guide We forgot to do classifying, I think. I didn't see any classifying there, so let's do some classifying, just because we are going to need to know classifying for the test. If we're going to classify, let's talk about this one. If we classified this polynomial, this would be a 4th degree polynomial of 1, 2, 3, 4, 5 terms. If we classify some more, I'm just looking at ones that already worked out for us. Right here, if we classified this polynomial, this would be a cubic polynomial, because cubic comes from the degree, and then 4 terms, because there's only 4 terms that are there. Let's continue on. Here we have another cubic polynomial, but rather than calling it a cubic polynomial of 3 terms, we call it a cubic trinomial. I'm just kind of going through, just labeling. Here we have a quadratic, but I'm only looking at labeling terms of that don't have remainders, like right here. Here we have a quadratic trinomial. And so at the quadratic trinomial, that's just the trinomial of 3 terms to the 2nd degree, but we formally call it the quadratic trinomial. And I think that's pretty much good. That should cover that. And I'll give it a little bit more time. Let me send out a text. Let me access the remind on my computer just to send out a remind for y'all. And once I do that, we will get at it. Remind. Write a message for 6th, 7th period. I am now reviewing the old material. If anyone needs to look at those, here is the link. And sent. And I'll give about a minute of that just to see who picks up. And then we'll get at it, because I know that this is a long podcast. Some things I want to make sure that we look at. I'll just kind of look through square root method. That would it's good to know the quadratic formula, how to solve problems with quadratic formula, but we've already had enough practice with the quadratic formula. We'll talk about we've done enough with square root method. I'll do 19. I'm going to circle these just so for me, looking at 19. I'm just kind of looking through the review guide, seeing what would be good to do. Might be good to do this one rather than multiply. We'll call it simplify. See what happens. How to simplify this. We've done quadratic formula. Might be good to work on just some practice here and some practice of absolute value. And probably work on some practice of using elimination. Might be good to look at inequality too. So we'll look at inequality as well. That'll be good for our review. Yeah, let's do that. So I've given enough time. Not seeing any comments being made yet. For if you just joined, just make a comment. I don't see any comments being made on, hey, can you do this or do this type of problem. I know Michael did mention graphing. I will say there will be no graphing on this test for the review guide. So Michael, if you watch this part of the podcast, you don't have to fret or worry. And so that being said, all right, we got 3 viewers. If you're here with me, comment now, just so I know who's with me and things like that. All right, let's get it going then. And so what I've done, if you're just joining us, we've worked out the first 17 problems. And so we've worked out the first 17. Go back and look through those. I'm just going to work out a select 1, 2, 3, 4, 5 more problems, 6 more problems. Just a couple of them, not all of them, just a couple, because I just want to, I got to get home. So I can't spend all my time working all these out. So let's talk about solving through the square root method. So to solve by the square root method here, I have x plus 5 squared is equal to 9. My goal is to get this x by itself. And so to do that, what I'm going to do is square root both sides, which will give me x plus 5. Now, when we square root, we are left with the positive and negative square root of 9. Now, the positive and negative square root of 9 is really the positive and negative 3. And when you have an equation equal to 2 values, that's essentially saying that x plus 5 is equal to 3 and x plus 5 is equal to negative 3. And so what we're going to do is essentially just subtract 5 on both sides to find out that x is going to be equal to negative 2, and subtract 5 on both sides again to find out that x will also be equal to positive 2. So then our answer will be positive and negative 2. They're not always the inverse of each other. It just happened to work out that way. And oh, oops, shouldn't be a positive 2. Negative 5 minus 3 is not positive 2. It's actually a negative 8. Sorry for that. Let's continue on. That's the square root method. I'm not working out a quadratic formula because we've already worked out 2 of them, so you've seen it. Just make sure for the quadratic formula, the polynomial must equal 0 before you do it. It gotta equal 0. And so with that, let's kind of go on simplifying here. Notice for this simplifying, it's 2 equations multiplied by each other. So we'll FOIL. We'll do 5 times 3, which will be 15. 3 times negative 4 to get negative 12i. 2i times 5 to get positive 10i. And then 2 times negative 4 to get negative 8i squared. Now, just a reminder about this I squared value. I squared is equal to negative 1. So this is really negative 8 times negative 1. And then that will be equal to 8. For Abby, hey, Mr. Lawless, can you go over a long division problem? I have done that already. I've gone over both of them on the study guide. And so after this podcast, Abby, just going to let you know, I will post it, and then the long division problem will be up. And then that way, if you do have further questions, we can talk about it in class tomorrow, or you can swing by in the morning and we can work through it that way. So that's just kind of, we've already worked through those, but appreciate the question. Really appreciate that. So let's continue back to the problem. We have 15. Oh, where were we? We're multiplying negative 8 times this negative 1. The reason that we did that is because we have 15 minus 12i plus 10i, which is going to be a positive 8. So now we're just going to combine like terms. So you're going to add 15 and 8 together, which will give us a 23. And then you'll do negative 12 plus 10 to give us a negative 2i. And so your final answer should be 23 minus 2i. And that's in standard form, which is good for us. I like standard form. Let's keep going. I'm kind of getting tired, so I'm rushing through these. And you're welcome, Abby, no problem. Let's talk about this one. So to solve this, what we need to do is essentially get the x by itself. Now, I know there's brackets and parentheses. There's a lot there. Oops, sorry, hit the wrong one. You want to work always from the inside out. So looking on this left side, inside out, this essentially, this parentheses will become the negative of 6x plus 4x plus 8 equal to 3. And I'm just going to distribute that negative 1 minus 6x minus 4. And so from that, we can combine the terms on both sides. And when we combine the terms, we will get negative 10x plus 8 equal to negative 1 minus 6x. The goal is to get x by itself. Now, the difference between brackets and parentheses is nothing really. It's just to distinguish, hey, you have two groupings going on. So then this is a negative 1, and we're going to distribute that negative 1 across. So we're looking at negative 10x minus 8 is equal to negative 1 minus 6x. So we want to solve for x. So what I'm going to do is I'm going to add 10x on both sides. And that'll give me negative 8 is equal to negative 1 plus 10x. And then I'm going to add 1 on both sides to get me 10x is equal to negative 7. Now, from there, I'm going to do some, oh, sorry, that should not be a 10x there. 10x minus 6 is actually a 4. I got to erase that as well. And so with that, I'm going to divide both sides by 4. And then x will be equal to negative 7 over 4, which in our case is D. Another thing that you could do is just plug and chug. So plug in answers for x until they work out. But again, some of these might not be multiple choice, and it'll be good to know how to do it without multiple choice. Next question we have is an absolute value equation. And so an absolute value equation, this has been a while, but what we have to do for these is essentially get the absolute value by itself. So to do that, what we're going to first do is add 2 on both sides to get 5 absolute value. X plus 3 is going to equal to 7. Now, we don't distribute this 5. Don't distribute that 5. We're actually dividing that 5 out. So then we'll get x plus 3 is going to equal 7/5. So I know we're dealing with a fraction, but don't freak out. Fractions aren't terrible. So essentially what this is going to do for us is it's going to break it up into 2 parts. One part where x plus 3 will equal a positive value, and the other part where x plus 3 will equal the negative value. Because essentially that's the value, it needs to equal either one of these. So what we'll do is subtract 3 on both sides. And when we subtract 3, we need to find a common denominator. So that's essentially multiplying this guy by 5 over 5. And so that'll be 15 over 5. So then we'll get x should equal negative 8/5. And then let's do that for the other side here. And so we'll subtract 3 on both sides. And I've already found out if I multiply 5 by 5, that'll give me 15 over 5. So x then will also equal negative 22 over 5. And that answer correlates with B. For 26 here, this is solving. I want to solve for the y value. Let's do this by elimination. For elimination, I want to essentially solve for y. So one thing I can do is multiply this guy by 3 and then this guy by 5. The reason I'm doing is I want to get rid of these x's. If I get rid of the x, I'll get y by itself and I'll be golden. So when I multiply the top part by 3, my new equation will be negative 15x plus 24y equal to 168. my bottom equation then. So since we'll multiply this by 5, that will give me 15x minus 20y. It's going to equal to negative 140. When I add these two, the reason I didn't have to multiply by a negative value or anything like that is because one of the negative, one's positive, one's negative. Oh, I'm multiplied by a negative 5, sorry. The reason we multiply by a negative 5 is I need to make one of these positive, one of these negative. And so that gives me a positive 15x. So essentially what that does for me then is cancels out the 15 and leaves me with a 4y equal to 28. Well, all I got to do to solve for that is just divide both sides by 4, and y is equal to 7. And that's just solved through elimination. I just like to use elimination. If you like to use substitution, you do that, but elimination will be easier for this problem. And the last problem for our review is going to be looking at an absolute value inequality. So for this absolute value inequality, what we got to do first is get rid of that 6. It's the same premise of the absolute value equation, is you got to get the absolute value by itself. So that would give us the absolute value of b plus 5 will be greater than 9. Now, when you're doing the absolute value of an inequality, what that means is you're going to take b plus 5 of the positive. But when you take the negative value, one thing we have to remember is if you change it to a negative, you got to flip the sign. Or flip the inequality. And so we're just going to solve both of these. And so to solve these, we're going to subtract 5 on both sides. So then b will be greater than negative 5. And then on this side, we'll subtract 5 again. So then b will be less than negative 14. So then the question is this an and statement or an or statement? So b is less than negative 14. It's greater than negative 5. So b, if you can write it where b is in the middle. Actually, do this way, sorry. B is greater. So if I drew this on a number line, if I had a negative 5 here, I know that b is greater than negative 5, and I have a negative 14. I know b is less than negative 14. So this then would be an or statement. And so our answer then would be B. And that's it for our podcast. Any questions before I go? I appreciate y'all listening. I'm going to stop it now, and I will see y'all on the morrow. Thank you and good night. Go Dogs.